Hi all, welcome to Learn Code Repeat. So today we'll be looking at day 28th of the September LeetCode challenge. The name of the problem is subarray product less than k. Let's look into the problem. So the problem says you are given an array of positive integer nums. Count and print the number of contiguous subarrays where the product of all elements in the subarray is less than k. Okay, we'll look into this example later. The constraints are nums.length is less than or equal to 50,000 and greater than 0. Nums of I, so the elements in the num will always be greater than 0 and it will be less than 1000, and k, right, the value of k will be greater than or equal to 0 and less than 10 raised to 6. Okay, so here itself if you see k is said to be greater than or equal to 0, whereas nums will be greater than 0, right. So if nums of I is greater than 0 and k is greater than or equal to 0, in that case when k is 0 or 1 we should always return 0, right. So based on the constraint that can be our base condition. So let us look into this example. Okay, so this is the example here. So here input is 10, 5, 2, 6, k is 100 and the output is expected to be 8, right. So what it means is then we have to find the sub array such that the product is less than k, right. So for example, let us say we are not looking at k equal to 100, let us say we are looking at k equal to 200, right. So in that case it will be 10 into 5, 50, 50 into 2 is 100, 100 into 6 is 600. So let us say this is not even 200, let us say this is 700, right. So that all the numbers in the nums array is eligible, right. So in that case what will be the count, right. So the numbers will be something like this, right. If I start from left to right, so first it will be 10 and then it will be 10 comma 5. So 10 is less than, if I take k as 700, so 10 is less than 700, that is fine. 10 comma 5 is 50, which is less than 700. Then I will take 10 5 2. So 10 5 2 is 5 into 10 50, 50 into 2 is 100, 100 is less than 700, that is fine. Then I will take 6 as well, 10 5 2 6, which is 600, so that is also less than 100, which is fine. Then once I am done with all the numbers starting from 10, then I will go with the second number, which is 5. So it will be first only 5, 5 is less than 700 is fine, then 5 comma 2 and then 5 to 6, so on. Similarly then the number starting with 2, I will have only two numbers, 2 and 2 comma 6, and similarly the number starting with 6, I will have only one number, right. So if you see the pattern right here, if there are in total 4 numbers, then there are 4 plus 3 plus 2 plus 1, right. So these are the counts. So 4 plus 3 plus 2 plus 1 is in total 10, right. So there are in total 10 numbers that can be formed, right. Now in this case coming back to k equal to 100, right, we see that 10 5 2 is not eligible because it is 100 and 100 is not less than 100, so this is not eligible. Similarly here this will be 600, so 600 is greater than 100, so this is not eligible, right. So the rest of them, right, 5 into 2 is 10, 10 into 6 is 60, so 60 is less than 100, so that is eligible. So the rest of them will be eligible. So in total it was 10 and we cancelled out 2, so remaining is 8, right. So that is same as the expected output, right. So the way we checked was we first took one number and then we took the next number along with that one number. So first 10, then 10 5, then 10 5 2, then 10 5 2 6, right. We started adding each number from the right into our list, right. If that is, so our list will be first of only single number, then the next number, then the next number and then next, right. After that I will increment my left counter so that I start my list with 5, then 5 2, then 5 6, right. So our question, right, if it would have been instead of count I would have to return the actual list containing all these numbers, right. Then in that case I would have to do two for loops, one to go over this whole list and second to have the new list with the starting index, right, first with 10, then with 5, then with 2, then with 6, right, like we did here, right. So in that case our algorithm would have been n square, right. So this would have been the algorithm in that case. What I am doing here is I am having one loop where I am going over all the numbers once, and within that I am calling this update prod count where I am having a start index which is my value of I. So from start index I am again doing a recursive call here. So this is similar to one more for loop, right, and whenever my product is less than k I am adding that into the list. So my list will be formed, and here if you see I am trying to do CNT. So if I would have to return the number of elements, right, in that list, I could have returned using this approach as well, but since I am only interested in the count, right, I do not need to unnecessarily form the list and find out what are the list elements, right. So if you go by this approach, this is the n square algorithm, and for this particular problem in LeetCode will give you a time limit exceeded error. So let us see how we can do this in a more optimized fashion, right. Let us go back to that example. So here to check the elements, right, we first added 10. So let me write down here 10, 5, 2, 6. So our logic was we went from left to right, we created a window. First we created a window of one element and kept 10 as the starting point. Then we added the next element 5, then we added the another element 2, and then we added 6, right. Now while doing this, right, I am also doing the product, and I will check whether my product value is less than k. Now when it comes to this particular point, right, if my product is greater than k or greater than equal to k, right, then I do not need to go to the rightmost side, right, because it will be more than that value, right. I need to break till here, right. So in our case, right, 10 into 5 was okay, but 10 into 5 into 2 is greater than k, right. So I can break here and then I can start with the next starting point which is 5, okay, and then I need to go to 5 2 and then I will check 5 to 6, right. So what I am trying to do here is I am creating a window. First I am going through this. Whenever I find that if my product is greater than or equal to k, right, in that case I will remove that number from the left side and I will try to add a number from right side and see whether I am able to find a product which is less than my k, okay. So that is what we did here. We removed the number on the left side which was 10, and then we kept the number on right side, and then we tried to increment that and see whether we are able to find a product which is less than k, okay. So that way we can do the sliding window. However, how can we find the count, right? Though we are doing this here this way, but still how can we optimize the for loop so that we can have only one pass over this array and get the correct count, right? So if you observe here, right, when my number is 1, at that time my element is only 1, right. When my number is 2, that is 10 and 5, right, what are the number of combinations that I can have for the product, right? I can have 10, I can have 10 comma 5, or I can have 5, right. When I am having 3 numbers, assuming that let us say k is 700, right, so or 3 are valid combination, in that case I can have 10, 10 comma 5, then there will be 10 5 2, then that is the number starting from 10 is done. So now we have to start with 5, then it will be 5 comma 2, and then at the end it will be 2. So 1 2 3 4 5 6, so there will be 6, right. If you see the pattern here, right, so for one digit it is 1, for 2 digit there are 3 numbers that we can have, for 3 digit there are 6 numbers that we can have, right. So the pattern is similar to n into n plus 1 by 2, right. So if my n is 3, so 3 into 4 will be 12, 12 by 2 is 6. So that is what we are getting here, right. So n into n plus 1 by 2 is same as like if my number is 4, so it will be 4 plus 3 plus 2 plus 1, okay, which equal to 10, right. 4 plus 3 is 7, 7 plus 2 plus 1 is 10, which is same as 4 into 5 by 2, which equal to 10, right. Same is seen here as well. If all the 4 number were eligible, so we first got 4, then we got 3, then we got 2, then we got 1. That is what I am showing here, okay. So we can use the way the count is formed here in this case as well, right. So when I am using 10, right, my count will be 1, okay. When I am using 10 comma 5, right, these are the 2 numbers that is eligible. At that time I can have, previously it was 1 and now the length is 2, so 1 plus 2 which is 3. Now when my length is 3 for the array, assuming all 3 are eligible for the product which is less than k, in that case it will be 1 plus 2 plus 3. So here plus 3 will be there, so 3 4 5 6, So when my length is 3, I will get the count as 6. Okay. So we can do this way, that means at each point if the product is eligible, then find out the length. So we can have a pointer here I, a pointer here j. So j minus I plus 1, because it is a 0th base index, so we have to do plus 1. So j minus I plus 1 will give me the length of this particular range, and we just need to add it to the counter. So this is the result that I am having, right? Result plus equal to j minus I plus 1. So this will be the way I will calculate my count. So that way we can find out the count for the total number of elements whose product will be less than k. Okay. Now also take the other condition where if the product is not less than k, right, that means the product is greater than or equal to k. For example, in this case when we do 10 into 5 it is fine, but when we do 10 into 5 into 2 it gives us 100, which is not less than k, right. What should we do in that case, right? So in that case we will try to increment the leftmost pointer. Let us say the leftmost pointer is I and rightmost pointer is j, right. So we will try to increment the leftmost pointer so that the leftmost element is removed from the product, right. So that means to remove the leftmost element from the product, right, we have to do product divided by nums of I, right, provided I is my leftmost element, right. So that will give me the product value which is not having the leftmost element, right, and then we will check if the current range is less than k, and if the current range is less than k, then we will continue our loop with adding the next rightmost element. Okay. So we will check this logic again when we are coding it, right. So let us try to code this. So the first thing that we checked was if k is less than or equal to 1, then we have to return 0, right, because of the constraint here, right, we are saying nums of I is greater than 1, but k can be greater than or equal to 0. In that case, when k is 0 or 1, we will never be able to find out a product, right. So in that case it will always be 0. So if k is less than or equal to 1, in that case directly return 0. That is our base case condition, right. So let us define the int result equal to 0 and I equals to 0. I is my left pointer. So here j will be my right pointer. So initially left and right both will be at 0, and let us say I am doing the current product. So let me declare this current product here equal to 1. So current product equal to current product into my nums of j. Now if my current product is greater than or equal to k, right, in that case I need to remove the leftmost element and try again and check whether my current product is less than k. But if it is not, then again I have to remove the leftmost element. So I have to do this in a loop, right. So let us use a while loop. So current product equals to product divided by nums of, now my leftmost pointer is I, so nums of I, and I will increment the pointer after that. So I am removing the leftmost element from my current product, so that is why I am doing the division here, and after that I am incrementing the value of I, that means I am incrementing the leftmost pointer. So I will do this in the while loop until my current product is greater than or equal to k, and it will come out of the while loop when my current product is less than k. So my result will be result plus whatever is the range I am having, right. So j minus I plus 1, that will be my range. So here it will be j minus I plus 1, and at the end I can simply return the result value. Okay. So the complexity of this will be O of n, because we are going over the array only once. Here even though inside we are using the while loop, but it won't be for all the cases. So the amortized time will be always O of n here. So let us run this solution, and this is accepted. Let us submit it. So that's it for this video, guys. If you have any questions, please write down in the comment section, and do subscribe to the channel for future such videos. Thank you.